If f of x equals x squared, find a formula for f prime of x, then compare the graphs of f and f prime. So we're taking the derivative, which means that we need the limit definition of the derivative. And there it is magically. But what we have to do is we have to substitute in our specific function here, f of x equals x squared. So we've got the limit as h approaches 0 of, in this case, f of x plus h is going to be x plus h quantity squared, minus f of x is just x squared all over h. So we need to expand the x plus h quantity squared. That gives us a perfect square trinomial, x squared plus 2xh plus h squared, and then minus that x squared that was already there, all over h. Now we have some cancellation that happens. We've got a positive x squared and a negative x squared. When we subtract those, that gives us 0, so those go away. And then we can actually divide each of those terms by h to separate those out. If we take 2xh divided by h, the h's cancel, and we're left with 2x. And then if we take h squared and divide it by h, that gives us an h left over, 2x plus h. And as h goes to 0, that second term vanishes, and we're left with 2x, which is our derivative function. So we're asked to compare the graphs of f and f prime. I'm going to do a rough sketch here. Not the nicest in the world, but life will go on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, etc. All right. Perfect. Our original function f of x equals x squared is a parabola. The vertex is the origin, and then it goes through 1, 1, 2, 4, 3, 9, and negative 1, 1, negative 2, 4, negative 3, 9. Looks something like this. This is our graph of y equals f of x. And then f prime of x is y equals 2x. So that is a line that goes through the origin and has slope 2. So it looks something like this. Y equals f prime of x. And then if we look and compare these, the derivative is positive on the right-hand side and negative on the left-hand side, which makes sense because the function is increasing on the right-hand side, hence a positive slope, positive derivative. And on the left-hand side, it is a decreasing function, hence negative slope, hence negative derivative. The derivative is 0 at the origin, at x equals 0, and that corresponds with a horizontal tangent line, slope 0. So we can see the connections between what the graph of the original function looks like and the graph of the derivative.